Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, I'll be showing you how to deal with calculations with regards to chemical equilibrium, or rather the equilibrium constant. Are you together? But before, guys, I do that, please, guys, do share the video to your peers. I believe that a thing or two that I'll mention here might help them either elevate their knowledge in chemical equilibrium, excuse me, or even help them prepare for the upcoming exam. So please, guys, do help us grow the channel as well by just subscribing. Okay, we are told that carbon monoxide gas reacts with water vapor at a temperature of T degrees Celsius. The reaction reaches equilibrium according to the balanced equation. Okay, and then we are told that initially 0.6 moles of carbon monoxide, 0.6 moles of water vapor, 0.1 moles of carbon dioxide, and 0.1 moles of hydrogen were mixed in a sealed flask, which is just 2 cubic decimeter. Okay, and then we are told that if the equilibrium constant Kc for this reaction at T degrees is equal to 4, calculate the mass of carbon dioxide present in the flask at equilibrium. Okay. Obviously, guys, we are going to draw our table over there. The first row, we just have our initial number of moles, and then the most important row, which is the second one, that's where we'll find the number of moles that we used and the number of moles that were produced. Are you together? Remember that we use our reactants to form products. That's why we will subtract from our reactants, but we will add on our products. Né? We use our reactants to form products. Please keep that in mind. And then obviously over here we will have the quantity which is left at equilibrium, and obviously have the concentration at equilibrium. It's very important, guys, to find the concentration, because if ever we are given the equilibrium constant, we can only calculate the equilibrium constant if we know the concentration of both our products and reactants at equilibrium. Okay, remember that the volume of this flask is just 2 cubic decimeters. We were told that initially 0.6 moles of carbon dioxide was present and 0.6 moles of water vapor. And then for the products, we just had 0.1 and 0.1. Okay, we were not told, guys, the amount of, rather the quantity which is present at equilibrium. However, we were given the equilibrium constant. So since we are given the equilibrium constant, I believe that we can find the quantity which is present in the flask at equilibrium. Yeah? Okay. I do not know how much I used for my carbon dioxide. So if I can just call this amount X. Are you together? So that means I have used X amount of moles for me to form my products. Are you together? Okay. Since, guys, the ratio is just 1:1. 1:1 over here. That means I've also used the same amount for water vapor, and that simply means I've also produced the same amount as well, because the ratio is just 1:1. Are you together, guys? So therefore, the amount of carbon dioxide, rather the amount of carbon monoxide present at equilibrium, I'll simply have 0.6 minus X. These are the number of moles which are present at equilibrium. Remember that initially I had 0.6, but I've only used X amount of moles. That means I will be left with 0.6 minus X. Do the same thing over here. I have 0.6 minus X. But for my products, guys, since I'm producing more products, or rather I'm forming more products, I will add on my products. So I'll simply have 0.1 plus X, 0.1 plus X as well. So these over here, guys, represent the amount of moles present whenever our reaction reaches equilibrium at T degrees Celsius. For me to find the concentration, guys, I just need to take the number of moles at equilibrium divided by the volume. Our volume is 2 moles per cubic decimeter, so the concentration of carbon monoxide is just 0.1 1 minus x all over 2. It's 0.6 rather, excuse me. It's 0.6 minus x all over 2. Same thing applies over here, all over 2. And then I'll simply have 0.1 plus x all over 2, 0.1 plus x all over 2. So now I do know my concentration, of both my reactants and products at equilibrium. Remember that, guys, for me to use Kc, I should know that the Kc value is basically equal to the concentration of products all over the concentration of reactants, right? So our products will simply have carbon dioxide and hydrogen. And then for our reactants, we had carbon monoxide as well as water vapor. Kc is equal to that. Né? Okay, but we are told that, guys, the value of the equilibrium constant is equal to 4. Please remember that. So I'll just substitute 4 over there. And then my concentration for carbon dioxide is just 0.1 plus x all over 2 multiplied by another 0.1 plus x all over 2 all over 0.6 minus x all over 2 and 0.6 minus x all over 2. All I just did here, guys, was to just substitute the concentrations of my reactants and products at equilibrium. I still have 4 over there. At the top, guys, I have two things multiplying. If ever, guys, you multiply numbers of the same base together, just take one base and then add your exponents. There's 1 and 1 there, so I'll simply have a squared. Same thing applies there. I'll simply have 0.1 plus x all over 2 all squared divided by 0.6 minus x all over 2 all squared. I can simply take the square roots on both sides, and then I'll end up having let me just enter the square root. The square root over here and the square root there. I'll end up having 2 on the right hand side, and then 0.1 plus x all over 2 divided by 0.6 minus x all over 2. Okay. Before we continue, guys, whenever I deal with fractions, I don't want to have a fraction within a fraction. I just want to have whole numbers divided by whole numbers. So how can I remove that fraction over there? I can simply multiply the top and bottom by the same LCD. Are you together? So the only denominator I have is 2, both at the numerator and the denominator. So I'll just multiply the top and bottom by 2. By just doing this, I'm not changing anything. 2 over 2 is equal to 1. Okay, and then I'll still have 2 on the left hand side. Then this term over here multiplied by the 2, the 2's will just cancel one another. I'll be left with 0.1 plus x all over 0.6 minus x, because these 2 will cancel with that 2. Né? Okay, and therefore I can simply cross multiply. I'll simply have 2 as 0.6 minus x is just equal to 0.1 plus x. 2 times 0.6, that's 1.2, but let me confirm. 0.6 times 2, yeah, that's 1.2 minus 2x is equal to 0.1 plus x. I can therefore, what can I do? I can therefore group the like terms. Né? I'll simply have 1.2 minus 0.1. This is equal to x plus 2x. I've taken this to the other side, it became positive. I've taken 0.1 to the other side, it became negative. Né? Okay. Then 1.2 minus 0.1, that's just 1.1 is equal to 3x. Divide both sides by 3. If I divide both sides by 3, what do I get? Then x will simply be equal to 0.3667 moles. X is just 0.337 moles, right? But I was never asked to find the value of x. let us go back. We were asked to find the mass of carbon monoxide present at equilibrium. So I know that the number of moles of my carbon monoxide at equilibrium will simply be 0.6 minus 0. In fact, let me just write this final answer as it is. I'll round off at the end. Please guys get used to that as well. Yeah? You'll round off your answer at the end. How many 6's are there? 2, 4, 6, 8. 6, 8, and 7. So the value of x is just 0.366666667, ne? 6666667. So all over here, I'll simply say 0.6 minus the 0.36667. I'll simply get the number of moles to be 0.2333333. It's just reoccurring. So let me just write them as a fraction, guys, just to prevent making mistakes. So this is the amount of moles present at equilibrium. Are you together? So therefore, for me to find the mass of carbon monoxide, I know that number of moles is equal to the mass divided by the relative atomic mass number. The number of moles is just 7 all over 30. I do not know my mass, but the relative atomic mass number, carbon has a molar mass of 12, oxygen has a molar mass of 16. Carbon has a molar mass of 12 and oxygen has a molar mass of 16. So this is just 7 over 30 is just equal to m all over 28. If I just multiply both sides by 28, this will cancel with that one. Therefore, m will be equal to 7 over 30 times 28. 7 over 20 times 28. And then the mass of my carbon monoxide gas present at equilibrium is 6.53 grams. That's how, guys, we're supposed to deal with this question over here. So please, guys, do stay tuned and wait for more videos. Thank you.